Thank you very much for joining us for our masterclass this afternoon, which is Energy Management Innovations in the Food and Beverage Industry. Charles Anderson is one of our panelists there. Hi, Charles. He's a Director of Process Optimization here in Cool Planet. And Colin Martin, our Global Sales Director. Well done, Colin, for working around those technical issues that we were having. So, great sign up. Obviously, lots of interest. Well, there would be with the energy prices going as they are. If we can reduce your energy costs, that'd be great. Little bit of housekeeping. As we all know, Zoom calls. We've got chat box and a Q&A box at the bottom. If you have any questions while the gentlemen are running through the masterclass, pop them in the bottom. If I can, I'll put them to them during the masterclass. Otherwise, we have 5-10 minutes at the end of the class for you all to chat. Bless you, Colin. So I'm going to hand over to the gentleman now, and
Colin,
Charles.
Go ahead.
Yeah, brilliant. Afternoon, everyone. Thanks very much for taking the time out today to join us. Hopefully this will be some useful insights that we can share with you today. Thanks for the introductions as well, Sinead. So as you know, we work for Cool Planet Group, and we've been in the energy efficiency space for over 12 years. And now that's sort of metamorphosizing, if you will, into the decarbonisation space and the sustainability agenda that's getting taken ever more seriously by most organisations, pretty much, and the public sector as well. So, in our view, the decarbonisation challenge, it's not just an accounting problem, it's not just an operations problem, it's not a sustainability person's problem. It really is a business transformation challenge. And we feel we're well placed to assist clients in sort of meeting, that challenge. So what is it that we do? Well, there's lots of things, but I think in trying to put this into one concise form, this slide is fairly handy in sort of capturing what it is that we do and how we can assist clients in the drive to decarbonisation. So as mentioned, this is really moving into that next level of energy efficiency in the race to decarbonise. No longer 5, 10, 15% cost savings, which topical, pardon the pun, not to be sniffed at. But really, we are looking now that, if we are to hit the 2050 targets, and a lot of companies are bringing them forward to 2040, 2030, you're going to have to make, huge step changes, 40, 50, 90% plus reduction in Scope 1 and indeed Scope 2 emissions, with Scope 1 probably being the trickier ones to achieve. Where we come from is that the foundations of everything we do now is through our software as a service platform, Clarity, which provides data generation, data management, acquisition, digitization, and analytics. So bring all the data into one place, analyze it, and start to see what's the potential roadmap for decarbonising. It's then builds into 4 main pillars. The pillar on the left is energy efficiency, what we've been doing for a number of years around steam systems optimization, refrigeration systems optimization, compressed air, your actual process as well, and looking at things and how we can make differences and really optimize a factory or a fixed installation's energy and indeed carbon performance with the assets that are in place and being used, and use them as smartly as possible to always ensure peak plant performance. Then move on into the next column, that the challenge there, electricity, Scope 2 emissions, relatively easy to, procure some green power and sort of tick that box. There is the Scope 2 emissions problem solved to a degree. Slightly trickier is heat, the thermal energy supply, particularly if it's getting used in steam or very high temperatures. But electrification of heat is definitely an avenue to be explored, and also into the transport sector as well. It's leading edge in terms of they are well on the way to shifting from internal combustion engines to electrical transmissions as the main mode of transport, particularly for road transport. But this could also move into industrial fleets like mining vehicles and other kinds of fleets as well, that we are well placed to sort of help and facilitate and assist on, whether it's from EV chargers or EV fleet management. In the industrial space around heat pumps, the electrification of heat, multi-stages to generate steam, and also that tricky portion of steam that can't quite be, it's at a higher pressure or temperature. Potentially you could consider an electric boiler or direct electric heating to resolve that. And again, with a view that electricity is moving towards being generally a no and low carbon source of power for industrial use. And the third pillar then from all these renewables that are going to come onto the grid that will help drive that transport revolution and the electrification of heat transition. You're going to need more renewables, and you're actually going to need more renewables at time than you can be absorbed, can be used meaningfully on the grid. So that's going to require a lot more flexibility from an electrical and thermal standpoint, whether that's grid services around demand response or battery storage or thermal storage. And also it's an opportunity as well, as more renewables come on. The sun is always shining somewhere, the wind is always blowing somewhere. The digitization of the grids as well as data could then allow a true 24/7 green procurement of electrical energy for sure. So it's a great opportunity to be looked at in this coming decade. And the fourth and final pillar there is, as we mentioned, renewables become a key player, whether that's on-site, off-site, solar PV, solar thermal, wind, biomass on site, and again, cogeneration plants and how they could be transitioned or utilized to balance out the peaks and troughs of demand and consumptions, whether it's in your facility or interacting with the grid or clusters of facilities in a local network situation. But bringing all those pillars together on top, we should be hopefully able to deliver a goal, which would be a significant decarbonisation result. And just by way of an example, we're working with clients at the moment, and potential solutions are able to deliver 40, 50, greater than 90% scope 1 carbon emissions and reductions. So that is technology that's proven now, that has a commercial payback and can deliver those kinds of results right now on the thermal scope 1 emissions side, which would be a great step towards decarbonising. So that's what we do. Today, we're looking to cover some of the basics of that and steps that can be easily taken to help start the journey towards decarbonisation or reinvigorate it or refresh it. Also, then that moves into continuous improvement. Apologies, the vagaries of working from home. The continuous improvement element of that, and then what innovations are available right now, as we've alluded to there already with some of the examples of the studies we've done for clients. What innovations are available today to be implemented to move towards decarbonisation, and then what innovations should we be getting ready for tomorrow? And so I'll hand on now to this section to Charles.
Thank you, Colin. So yes, with that 4-step plan, the first one is, can you tackle the basics? Can you handle those simple things? And so I thought I'd start off with a bit of an anecdote, a story about one of the sites we visited not so long ago. Often what we've seen in food plants is there's a lot of effort put into developing the recipe and setting the thing up. And this was an example of that. The guys in the kitchen were using butter. They'd reach into the fridge, they'd pull the butter pot out, they'd bap it on the table a couple of times to loosen the butter, drop it into the grinder, and it would go into their recipe. When that recipe got scaled up to the large scale, the guys would reach into the fridge, pull out a 5-gallon bucket of butter, smash that on a steel table to loosen the butter, and drop it into the grinder. Worked beautifully, maintained the same recipe as was in the original process. But what they were noticing is they were going through about 1 steel table a week. So there's opportunities to maybe challenge that business model. And I wonder if, while we're going through, just think about some of the ways that they could have reduced their consumption of steel tables in that particular process. But as I say, this first section is really just talking about covering the basics, collecting that low-hanging fruit. The disappointing thing is that's available at a lot of sites and generally is still there. So one of the first and key things that we see and find really valuable is literally just pulling all the data together into one place. The reality for a lot of people today is that their DCS, their SCADA system, the data historian for the process is not sitting on the same piece of software as the lab information software. They have several meters that are maybe not connected to anything. They've got utilities and weather behavior and their cost of materials and logistics and supply chain are all sitting on different systems. One of the huge wins we often see is just bringing all that data together into a single platform, collating it together, and then using that standardized platform to produce the sort of reports that you're going to need to run the business anyway, the energy, uptime, corporate responsibility, yield type reports, or the profit and loss, the carbon impact, the quality reports that you have. So just pulling all that data together into one place can be really helpful. So to quickly walk through that journey, that might involve collecting all your sites from around the world and being able to zoom into each one of them independently. So that's what we're trying to indicate here. On the second one, you're going to pull all that generally information, the publicly available information together, the stuff that's really relevant to how your plant runs though. So in this case, we're using a local weather station to work out what the ambient temperature is and what the relative humidity is, because all those things are going to impact how your cooling tower works, how much heat you're losing out of the walls of your refrigeration room, those sort of things. Once we've got all that data together, we then dive into the detail in the site, and that can involve both pulling together the instrumentation and the data historian, but also pulling together that fundamental engineering knowledge. There's usually a decent sized library scattered across lots of different locations of the original specifications on the machines that are in place, photographs or 3D scans of how the plant is laid out, P&ID drawings, maintenance records. If we can bring all that information together into a common platform so that it's available at the tips of your fingers, that's a really big win. And then, of course, you start connecting in your meters. And so you can start seeing how the individual meters are moving in near real time, but more importantly, how they've been behaving over history, so that you can see this is what's happening right now. This is the average, the hourly average of what happened last week. And when I had that problem last September, this is what was happening in all the different parts of the plant. So I can go back, learn what I was doing, and reapply that knowledge now or in the future. Really simple example. And again, the point of this is step one. This is tackling the basics. But we went to a site. They had two identical compressors. They had the same model, same history, same maintenance data, and they were switching from one to the other each day. So they kept the maintenance hours on those two compressors about the same, operating hours on the two compressors about the same, but they always had one as backup in case the system went down. And just by plotting the ampage draw off of those individual compressors, it quickly stood out that one of them was consuming 30% more electricity than the other. So what we could do fairly easily was go in and then question them, why is this? What's going on? And they very quickly were able to say, no, look, this has got this problem, and they fixed it. And it wasn't a huge saving. It was a few $1,000s a month, but it was a few €1,000 a month that they were wasting, and that electricity that was going down the drain. So it was worth doing. And a whole series of those little wins start adding up and becoming something bigger. So the second slide I was going to talk about from that perspective is this. So this is sort of the KPI management. So again, if you have all that data on hand and you can see it instantaneously, you can start looking at multiple different sites for multiple different things, and you can quickly scan through it and see, well, look, this site A has got a problem with its fuel. So let's drill in. Where is it having its problem? It looks like it's having the problem in CIP. So let's drill into CIP. And it looks like it's the heater on the acid tank that's not working. And this is the history. So you start getting that contextualized information for how your whole process is working. And you can very quickly drill down from the big picture corporate view to the individual piece of equipment to work out what the problem is and what's going on. I'll pass it back to Colin.
Thanks, Charles. So as we talked there, that was the basics and the start of the basics, but how can you make that slicker moving forward? You've got all your information, all your data in the one central place and platform. You've perhaps automated your reporting. What you'd really want to do now is actually spend some time analyzing this data and seeing what problems or opportunities can be identified and what actions you might need to take from that, whether it's simple set point changes or changing the control on a compressor or a set point on a boiler, or is it more into some deeper changes required that maybe we need CapEx and some design concepts, detailed design, procurement, implementation, but ultimately they come back into, have you made a saving? Have you made a step change? Confirm that effect, sustain and maintain those savings over the short, medium and long term. Now, bringing that data into one place, okay, then you need to bring in the specialists to actually have a look at that and come up with some ideas. And this can be, relatively straightforward in concept, but actually require quite a lot of expertise to implement and deliver. This very straightforward example in theory here is a biomass boiler at a South American factory. You can see there in the red line that it was operating around about 140 degrees stack temperature. Once we had that data centralized and in place, we felt that was a bit high. The typical benchmark there is 135 degrees or less. But with these large thermal systems, you can't just go and make that change without doing appropriate diligence. Our subject matter expert was very familiar, great experience in these kind of systems. So he was able to analyze and deduce that the opportunity existed. He was also able to liaise with the OEM, the original equipment manufacturer, to actually check, there wasn't a design reason, a technical reason, a criticality reason that, this could not operate at at perhaps a lower temperature. When that was confirmed back from the OEM, we were then able to unlock the setting on the dampers, adjust them, and to allow that temperature to step quite dramatically, in this graph at least, from 140 degrees down to 130 degrees, with no negative impact in the process, and still delivering steam at the required temperatures and pressures. And it improved the efficiency. It was a moderate saving, all in €33,000, about $39,000 per annum. But in terms of the time, the resource that had to be spent, it resulted in a 6-week payback. So quite straightforward in concept. It required the data in one place to be able to be analysed, but it also required a suitable expert to actually look at it and deduce that this was opportunity, it was real, and wouldn't have any negative impacts. If we move on to the next slide, please, Charles. Another perennial favourite of ours is steam traps and steam distribution, often an untapped area, an area that can yield savings. And with the sort of mechanical and floating ball type steam trap devices that are involved, that appear to just be on a perennial 6 to 36 month replacement life cycle journey. There's existing technology now, well proven, Venturi traps with no moving parts. They can cope with variable steam load if they're sized appropriately and correctly. And say they can cope with variable steam load. Previous generations, they perhaps struggled with those kinds of conditions. But there was no moving parts with minimal maintenance burden. They're provided with a 15-year warranty as well. You can sort of break out of that, say, 6 to 36 month replacement cycle. And what it can also do here, again, that low-hanging fruit, quite easy to go with, but probably need to bring in some expertise to do the study, to evaluate the trapping system, evaluate the distribution, perhaps even bring in the infrared technology, which traps have failed, which ones have failed to close, where there is issues. In this example here, we installed a complete upgrade. Again, moderate savings of 2% back when gas prices were sane. That's probably worth about $100,000 in savings now, but it also reduced carbon by 2%, 268 tonnes. And that's a step on the journey. Again, relatively straightforward, but needed suitable expertise to come in and evaluate and make those recommendations for change. And then the third example we have here is again in an industrial compressed air system, feeding compressed air to, in essence, a glass manufacturing facility. Number of compressors, 4 operating to and consuming around about 630 kilowatts of electricity as the baseline. Now, this is quite complex. There's a user requiring compressed air going directly into product. You do not want to impact the quality of product or indeed equipment uptime or downtime. So any impacts on production would be, severely penalised and a very dim view from the client. Observing the system and bringing all the data into one place and a suitable expert to analyse it and observe, there was ability to basically review the controller sharing mode settings, in essence, able to adjust the sequencing of the compressors to bring the most efficient units into more service, or the less efficient units with least amount of service. And that resulted in that first step change of 75 kilowatts electric drop. The next step was then to review the actual control parameter settings, what pressures were they kicking in and out and how they came in, the lead times and the lag times, and basically review that complete strategy. That resulted in the second step, 54 kilowatt electric drop, resulting in a total 129 kilowatt electric load reduction. And again, there was no hardware needed to be installed here. It was just having the data in one place that could be analysed and reviewed with suitable expertise to actually deduce the opportunity. And again, where required, liaise with the OEMs, liaise with the client, liaise with their quality people, and make sure there was going to be minimal risk of any downstream quality or production impacts. Thanks, Charles. We'll move on. So that was the basics, and it's alluding to we're needing, data, and we also need expertise. As we move on then into keeping that sort of going, continuous improvement, keep the low-hanging fruit trimmed, if we continue with our tree metaphor, and let's work up the tree as well to the slightly higher fruit and beyond. So you move on to the next slide, please, Charles. So one of the benefits of a system having all that information in one place, as Charles has touched on earlier, we can get to more dynamic KPIs, we can get to more timely KPIs, but also through the system, you can, instead of having to cut and paste from various spreadsheets, you can now set up automated KPIs, you can build models and correlations, And in our system, moving it through the workbenches into visualization forms on dashboards that can be organized as you see fit, fully user configurable, and can be shared within the organization to other sites within the organization, and also to third parties as well. Send them links to say, here, look at this report, look at this insights I've managed to gain from doing that. Also, what it provides, if you move on to the next slide, please, Charles, excuse me, is that ability to provide automated, actionable intelligence about what is happening in the process and track the responses and the responses to those kinds of events. Now, if you're familiar with the operational world, if you have maybe SCADA screens or HMIs, we're not just talking about, alarms and hysteresis and so on. That's not what this is about. This is more around, is the plant operating in the optimal conditions given the weather, given the production throughput, and given the existing equipment, technology, and designs that are in place. What this allows to do then is operators can receive timely, actionable intelligence to say, your system's been operating at respect for the last 2 hours, 4 hours, 8 hours a day, whatever the frequency may be, and they can take steps to remedy that. Then stepping back at management level or above, over say a quarter or 6 month or annual, you can actually review the data on a sort of longer term, more strategic basis to actually what was the main source of downtime in our plant last year, what would be the most effective deployment and efficient deployment of our CapEx to resolve the top downtime issues we had, or the most inefficient equipment we have in the plant. And it all comes from data as well. So you're able to make evidence-based decisions as opposed perhaps perception-based decisions. And getting that information into the right person or people or teams is pretty important. And in our system as well, we're able to do that in terms of KPI reports, whether that's by email or within the system and links sent to operators. But using the standard visualization of red, amber, and green, green being everything's okay, amber, concern, red, look at that as a priority, whether it's on an hourly basis, a shift basis, a daily basis, weekly, so on, whatever frequency you desire, that information get into the hands of the operators or the management or the quality team or whichever is the correct person to allow them to take action to ensure that the plant is always in peak performance based on the assets that are in place. And furthermore, this, as mentioned, it can all be shared within expertise, insight, different departments. And yeah, next slide, please, Charles. And into the wider ecosystem of the organization, the company, and indeed third-party outside experts. And a way of tracking that as well is a register of opportunities, which if anyone's had to get ISO 50001 or the other kind of ISO systems accreditation, there always tends to be a register required in these kind of systems. Here, whilst you can also upload documents, link dashboards, and the register of opportunities that we can develop gives you live data and tracking, allow you to enter the cost savings, the potential CapEx, and also share this, again, other stakeholders on site, off of site, and even the auditors when they're coming in, and it's proof that the system is in place, live and acting as it should. So if we move on to the next slide, please, Charles. So that's how it can all work, Slicker, when you bring it all together. It's the basics, but it's also into the continuous improvement loop. It should all be that virtuous cycle and circle. So that's great. And, it seems relatively straightforward. It seems like it should all be in place and working all the time. So why bother looking at this? Well, if it's not being looked after, it can often become broken. And often, and this might be an extreme example, this is sometimes what we observe when we go into client sites. The systems are all there. They should all be in place. They should all be acting correctly. But we find they're not. Maybe not all the data sources are being brought into one central point or place. Maybe some departments are looking after their own reporting and others are getting left behind. Is there that consolidated approach? Is there one source of truth to the data on site? Is all the data being captured? Or are you waiting for, say, invoices to come in and then you're a week or so behind the reporting deadlines? Or are you having to make estimations and assumptions of the data for the month end to then get ahead of that reporting cycle? Is then, in these days of lean and mean organizations, do you actually have resources on site or within the organization, suitable expertise to evaluate the data and the opportunities that could be hidden within that data? And again, do you have resources to make the change, particularly on the CapEx side or even the CapEx budgets? And is there perhaps maybe even a fear of change in the operational world? We made a change to that set point a few years ago. There was a quality issue as well. Not sure if the two are linked, but we don't want to do that again. And so the virtuous cycle can be broken. And that's why it's best to keep an eye on it. I'll hand you back over to Charles.
Mute as well. Thank you, Colin. I didn't mean to cut you off. The other thing though that's really important is it's not just about data. A big part of what I spend my time doing is trying to combine that instrumentation and that knowledgeable data of what's actually happening in the facility with the fundamental understanding of how does the process work, how should the process work. So integrating it with the fundamental design, the original intent, the equipment capabilities, but also the physical properties and the chemistry of what's going on in the real world. Building in the deep knowledge and experience that your operators, engineers, and quality people have of how that system is supposed to work. And so combining that together with smart tools to look at the data analytics is a really powerful way to turn that robust, timely data into structured, actionable, and fully leveraged information to let you move forward. A couple of examples of that, we were working with an oilseeds company where they had a quality measurement on the amount of solvent left in the oil as they're processing the oil. What we were able to do was convert that or supplement the offline analytical data where somebody had to physically take a sample, run it to the lab, get results back a couple of hours later, and then report what was going on, with a live online tool where we were taking the temperature and pressure at which that material was boiling, combining that with our fundamental understanding of the physical properties, what the vapor liquid equilibrium looked like, and then we could have a model that matched the data to see what was going on. And what that let us do is then give the operator a live and immediate feedback on what the performance of the system was looking like, and then leverage that to be able to adjust things much more responsively, much more quickly, to see what the problems were and get it lined out as quickly as possible. So that's some of the things that are starting to lead into the innovations with the technology that we have today. I mean, the point here is to go and buy that cherry picker so you can get the fruit at the top of the tree. What new machines are available? What interesting pieces of equipment or what changes are happening? Well, one of the big things that we're seeing right now is this shift globally, particularly in Europe, but globally, from having a carbon rich fossil fuel based power generation system to more and more of renewable energy electricity systems. So a lot more wind, a lot more photovoltaics, a lot more sort of tidal type systems starting to come in. Now, the advantage of those is that they are intrinsically not carbon. Once you've got the machines installed, they're not creating additional carbon. But the problem is the wind doesn't always shine, and the wind doesn't always blow, and the sun doesn't always shine. So what you end up with is this imbalance between the supply and the demand for electricity. So one of the things that we've been having quite a lot of fun with recently is trying to understand what can we do to try and level that balance out. The traditional approach of putting in a great big electrical battery does work, and it is often a really good solution. The nice thing about batteries is that they're very fast to respond, and they're really good to meet that sort of 1 to 2 hour demand. As time stretches longer than that, there's other solutions that maybe start coming into place. So we maybe look at thermal storage or demand shaping. We look at, can we integrate the car charging with the energy supply so that we can start using those car batteries as both a mode of transport, but also a way of offsetting the power. And so there's really interesting things you can do with moving those bits and pieces around. Why do we care about that so much? Well, fuel and everything else is getting increasingly expensive. This is some data that we pulled from a report that was interestingly from before the unfortunate occurrences in Europe recently with Ukraine going on. But you can see the real hockey stick shape that has been happening with the cost of carbon, the cost of electricity, and the cost of gas. What I think is interesting on the graph on the left is if you look at it quickly, it looks like the electricity price is going up more dramatically than the others. But I think that's actually just a scaling issue. If you have a look at what the price of gas has done, the price of gas is actually on a relative basis going up more quickly than the price of electricity. And I think that's what's really spoken to by the graph on the right-hand side, the relative cost of generating electricity as more of these renewables come into play, and as the renewables become more established in what they're doing, that cost of electricity, I think, is going to drop and become increasingly decoupled from the price of fossil fuels. And so the old traditional rules of the world where electricity is always 3 times the cost of fuel may be starting to change, cost per kilowatt hour equivalent. So what does that mean? That means we can start taking advantage of some of the newer technologies that are starting to happen. Heat pumps are something that have been around for a long time, but as the relative price of things changes, those heat pumps are becoming increasingly attractive. Historically, people have done low-grade heat pumps, but there's more and more that you can do at higher temperatures, and I'll talk about that in a moment. Adsorption chillers is another existing technology that's been around for a little while, but is increasingly attractive as the relative price of fuel and electricity moves up. Using your waste heat to do some of your cooling load can be a really attractive option, and we've been able to install a few of those. We've spoken about steam traps already. There's some new technologies around the Venturi. Not super new, but it's amazing how much opportunity there is by just doing, as I said before, the blocking and tackling of the basics. And then the final technology that we've been doing a little bit of work on recently is the concept of thermal batteries. So when electricity is cheap, you can heat up a big block of steel, and then when electricity is expensive, you can recover the heat from that block of steel. Traditional applications would maybe be turn that heat back into electricity. You get a relatively small, relatively low efficiency on that round trip. But in the food industry and the beverage industry in particular, we have a lot of uses for mid to low grade heat. So you can actually take that heat and use it directly in your process. And while a big lump of steel is a fairly expensive thing to buy, it's a lot cheaper than buying a lithium-ion battery. And it's much, much easier to maintain. And at end of life, it's still a big block of steel that you can sell back into the market. To talk really briefly about some of the heat pump applications, historically, heat pumps have been really good at taking sort of 20, 30 or below centigrade up to about 60 centigrade. A lot of applications in home heating, in hot water, in district. But what we're increasingly seeing is the opportunity to take that 65C heat and upgrade it into low pressure steam using alternative refrigerants. And what that does, once you start moving from the 60C back up into steam, you can then start applying mechanical recompression on that steam and taking the steam up to 3, 4, 6 bar relatively cheaply. And what that starts doing is it takes potentially a huge load off of your cooling tower and gives you back low grade heat. So if you think about, I don't know, a distillation column like we can see Aoife standing in front of here, I mean, you've maybe got cooling tower water condensing the vapors at the top of your column at 60, 70C, you're putting fresh steam at 100 and 110 at the bottom of that column. Well, if you could put a heat pump to link those two together, suddenly the only energy that you're putting into the system is the electricity to run that heat pump. And that can give you huge savings in terms of your carbon and fossil fuel bills. And it turns out with newer technology, you can get some reasonable paybacks as well. We're looking at 3, 4, maybe 5-year paybacks on some of these applications, but giving you 40, 50, in this case, 90% reduction in the overall carbon footprint, or at least the scope 1 fuel burning carbon footprint of your process. So that's a remarkable opportunity. The other piece that I'm really keen on is this application of mechanistic and higher end models. What you can do once you build that model is you can not only look for the traditional heat integration pinch type analyses, but you can also look at opportunities for how can I improve my yield? You know, every kilo that doesn't go down the drain is carbon you haven't wasted. It's profitable product for you in the end. You can look at water, you can look at capacity, but then you can also take those models and combine it with the sort of data that we're getting in our Clarity platform and build those insight models. So you start doing the soft sensors that I spoke about, or some of the targets that I'll speak about in just a moment. Here's an example of that. We were in a large, complicated oil seed plant where there's lots of different things happening, and there's many things that impact the overall efficiency of the process. So as the ambient temperature changes, I need to put more or less energy into cooling up the beans coming in, and my cooling tower performs differently. As my crop yield or my crop season changes, I move from having moist seeds to more dry seeds, or I move from having a year where I have a high oil content to a high protein content. And so my quality of my feedstock is moving around. And then finally, the vagaries of operation means that my overall throughput on the plant changes. what I was able to do with the detailed mechanistic model is turn that into a simplified statistical model in the space of operating relevance, and then put that model live and online, so you can start having, this is where the plant is running, this is where it could be running, and this is where it should be running if you had all your operating set points set the way we want. This is a quick example of showing that, but there's some really big savings available through really drilling down and understanding how the plant and how the process is working, and how it could be if there were no problems with heat exchangers or other issues, and then how it could be if you had all the set points operating exactly where you want them to be. With that, I'll pass you back to Colin.
Brilliant, thanks, Charles. So as we move into the next session, sort of the innovations for tomorrow, how are you going to plan your cherrywood furniture business for tomorrow and beyond? Now, we could, if you go on to the next slide, please, Charles, we could talk around, hydrogen's coming in as embryonic just now, and it ties in though to the excess of renewables that's going to be on the grid, over and above demand, and how to address the curtailment of power, so on and so forth. And there's going to be other technologies that come in that could be interesting in the mix. Thorium-based nuclear power is something that could be very interesting, given it minimizes nuclear waste and hazardous waste, and is inherently safe in terms of its operation and operability. But that's not going to appear anytime soon. Where we think that people have to be ready within most organizations is, activists, investors are starting to flex their muscles again. One of the strange outcomes of the pandemic has been that sustainability, decarbonisation is now sort of front and centre in most organisations thinking this is real. Governments are showing a willingness to actually act and compel companies to start doing things, particularly in the commercial building sector. We're finding in the UK and Ireland, they are actually under statutory requirements in terms of reporting and in terms of doing something to improve their kilowatt hour per metre squared of floor space metrics. So from our system, one of the things we think is really valuable is to have your real-time greenhouse gas emissions available. And as Charles is alluding to, with some of the sophistication we can implement through big data, having your live performance models, so dynamic tracking, it'll take more energy at the peak of the day in summer to keep the building cool and at a correct temperature than it will, say, in the autumn time when it's slightly cooler, and you can use the ambient air coming in to balance the comfort cooling within the building. So that's one of the benefits immediately available. But as we all know, scope 1 and scope 2 tend to be around about 20%. I think there was a survey done of, I think it was S&P 500 companies, and they estimated their scope 1 and 2 emissions, as they saw it, they're around about 21% of their emissions. 79% was their scope 3. And this was a problem because scope 3 reporting is fiendishly difficult with so many different standards and competing requirements. It's going to be very, very hard to really get a hold of this issue. Now, from our point of view, when we look at this, is someone's scope 3 is another person's scope 1 and 2. And just getting that scope 1, 2 information from, say, your key tier 1 suppliers would be a useful start. And getting that into, again, one central point or place that you could start to do your reporting from it as well. Again, it sounds basic and a straightforward concept. It's actually more difficult than it sounds to do. And again, that same survey of S&P 500 companies, a clear majority of them actually didn't report their scope 3. They made estimations, they made annualized estimations, and that was about as far as they could go at the moment. Imagine if you could start looking into your supply chain, get their real-time scope 1 and scope 2 emissions, and then start to see their performance, and then look to work with them to actually improve that performance and track that in one platform, and then bring that into your reporting that could then go up into the corporate management, but then also out into the investor world. And there'll definitely be increasing pressure from our view from investors for people to actually deliver on their science-based targets, to deliver on their commitments. It's no longer good enough just to say you have a plan, you're actually going to have to deliver on that plan. And the 2050 deadline will be on it before we know it, and a lot of companies are bringing it forward to 2040, 2030, and even 2025 in some instances. Within big organizations, though, the operating system for that company is quite a challenge, and often companies want to use one platform, whether it's Salesforce, SAP, or others. And this is key. We see that the way digitization is going and the way that discrete and disparate platforms can interact with each other through APIs, this is going to become more and more prevalent as companies say, okay, we don't, SAP may not have a module for this, but there's another system that does. We'll use that as our standard, but then we'll bring that into our SAP UX UI, and that's what all our employees are going to use. We'll have to train them once. It's all in the one place. They're familiar with it, and that is what we are going to use. So you're going to actually have one interface, we feel, but then behind it, there could be 10, 15, however many number of systems are needed to actually bring that information into one point that can then be used in a meaningful way by organizations and corporations. We'll move on to the next one. Charles, please. Another aspect that we think is, and innovation is maybe not the right word for this, is more tech for tomorrow's concern, in that water scarcity, water efficiency, and minimizing water waste is definitely going to come soaring up the sustainability horizon, and really compete with decarbonisation as two of the key elements of driving forward on the sustainability agenda. And why we mention this here is because some of those sacred cows that we mentioned earlier, and Charles will touch on just in due course, they nearly need to be reviewed and optimized to minimize food safety impacts and make sure you've got your kill steps and your HACCP compliance. But there is probably more optimal ways to conduct, for example, cleaning places or pasteurization cycles. But again, we come back to data. This is quite straightforward, and you could do it for electricity, you could do it for gas and thermal. In this instance, this is done on water. It's a hygiene water KPI. And in this dashboard, what we're doing is trying to gently foster some positive competition between the various shifts. It's basically tracking the water KPI on a shift basis, and that allows you to evaluate, is there some differences between night shift and day shift? Are you actually doing more hygiene on night shift? Should this be evaluated in a different manner? But also, is one shift perhaps got best practice and the other shifts are just on normal practice, and could that best practice be shared amongst them? So touching on some of the other key management topics to drive this kind of agenda, which is people's behaviors, people's understanding, people's levels of training. Going really down to a deep granular level, going, say, quite familiar in the food and beverage industry is bottling plants and lines, whether it's cans, beers, bottles, so on. Get to a SKU level and see what are your water, electricity and gas KPIs per product, per SKU, and what's the cost associated with that. And again, you could add in, sort of red, amber, green to provide a visualization here of what SKUs are performing as the requirement, and which ones are needing some attention, and which ones need to be prioritized. But furthermore, this then provides that actionable intelligence again. An anecdote we have is from a brand looking for a third-party brewer, and they said to the third-party brewer, our brand requires a flash pasteurization step. Third-party brewer goes, yeah, that's no problem at all, we can do that. But unbeknownst to them, and without really having the data in hand, they sort of knew that's going to be a bit costly because it's extra water, steam and electricity and so on to do the flash pasteurization step. But once you're able to evaluate how much that actually cost, then you say, oh goodness, they were actually going to lose money on that contract, on that SKU. If they have the data in place and have that intelligence to calculate how much that would cost, they can then go back to the brand and say, yes, of course, we can do as a third-party brewer, no problem at all. However, we need to put our price up by 30% because, and here's the data to show it, we're going to use extra water, steam, and so on to deliver that flash pasteurization step. So again, having the data and the intelligence really is empowering, whether you're just in a sales position or actually in the operational day-to-day position. So if I now hand over on to Charles, who then let's touch on those sacred cows that might need a bit of a shake-up.
Yeah, so as Colin says, it's all about the detail, right? It's all about challenging the sacred cows and getting deeper into the weeds on some of these things. So absolutely, in no way am I trying to recommend that we compromise on quality, food safety, or personnel safety. But there is occasionally times where those things are set up and viewed as untouchable. You have to do it this way because we've always done it this way. And the systems were maybe set up when the economic priorities and the operating priorities were slightly different. So one of the things I've touched on already and mentioned is the concept of combining those detailed computer models where you're using your fundamental chemistry and your fundamental physics of what's going on, turning that into actionable knowledge that sits inside of your system. And then you can maybe start supplementing, to some extent, replacing your physical quality tests with online live data. You get a much higher frequency of sampling, you get much faster feedback. You'll still do some of those live physical testing, but it moves from being the primary control parameter to being a check to make sure that your online systems are working and telling you how the system could be and should be operating. Lots of qualifications. I realize that's making people uncomfortable, but these are the sort of things that we maybe have to start looking at if we're going to continually edge that performance up slightly. Another area that I've alluded to, but I'll touch on again, is this concept of using thermal batteries. I could go out and I could buy that large lump of steel to put electricity into, but a lot of food and beverage companies have chilled warehouses or frozen warehouses, and those warehouses have an operating range in which they can the product remains at high quality. So could I use my frozen warehouse as a place when electricity is cheap to lower from the upper end of my temperature range down towards the lower end of my temperature range, store that cool, if you like. I've already rejected the heat. My material is colder. And then when electricity is really expensive, I can shut down my cooling system, let the temperature drift from -40 up to -35, and not take action until I start getting closer to that -35 and wait to take opportunity of those cheaper energy periods. The other area that we've seen a lot of interesting work around is those transitions, the set piece plays, but where you have the dynamics of things going through. So things like clean in place, product transitions, pasteurization to some extent. A lot of these things are kind of set and forget, right? I set the system up 30 years ago. This is how I've always done my CIP. I've got it qualified. I'm not going to challenge it. I'm not going to risk messing with the boat. You absolutely don't want to create a food safety issue, so I'm not trying to recommend that, but I'll show you an example in a moment of what I mean as to some of the potential opportunities there. And then product transitions are also an area of opportunity. So let me just jump straight into that CIP. Often what you see in facilities is that you have your CIP station in one part of the plant, and then a fairly long pipe that takes you to the part of the process where you're actually cleaning it, and then you have a fairly long pipe that comes back again, and that pipe can potentially recirculate some material or dump to drain. What you often see is people determine that they need 60 seconds of heat on the process, and so what they do is they turn on the hot water, they run hot water through the line, comes all the way through, and they wait until they see the temperature at the drain reach the target temperature. They start the timer, they wait 60 seconds, and then after 60 seconds, they shut off the hot water at position 1 and start the next step. What that does is it gives you a temperature profile like this at the different points within the system. It means that you're actually running hot water for something close to 2 minutes, despite only needing it for 60 seconds. And so if what you can do is you use this meter, this pair of meters to determine when to start and stop your CIP, you can still clean your process. You can still achieve the required time, temperature, and performance for the cleaning system. But you can do so with less hot water, so less energy, less water, and reducing the cycle time. And if that's not just for the temperature, but also for the acid and the base and all the rest of it, you can really compress your CIP time cycle down. You can save a lot of chemicals and you can save a lot of energy. This is obviously an extreme example. You don't really see this every day, but it's surprising how often this sort of opportunity does still exist. And it's not just in CIP, it's also in product transitions, pasteurization to some extent. Often if you've got a pasteurizer where you've got a canning or a bottling line and you've got a heat up, cool down, integrated water system, it's not uncommon to see that water over time has got out of balance. And so the central section where you have the hot water is overflowing and cascading hot water down the drain, while fresh cold water is coming in at the ends and being reheated with steam to get the process up and running. So those sort of opportunities exist, and it's difficult and challenging and complicated. And that's why it's important to combine the engineering effort with a communication effort. Part of what we do as Cool Planet is we have an education arm. We have a group that's dedicated to trying to help people understand, yes, it is uncomfortable. Yes, there are things that we're going to have to challenge about the way we've always done things, but there's a solid and a really good reason for doing that. And this is the way we're going to have to work if we're going to both take advantage of the opportunities that the changes in market prices, particularly around energy, are presenting to us, but also deal with the significant issues that we're going to have to around fossil fuel use and carbon footprint, and increasingly water use and other chemical uses as well. So that, I think, is where we're going to finish up. I posed a question at the beginning around that steel table reduction opportunity. I wonder if anyone's got any ideas as to what we might do, or if there are other questions that might be of interest. Sinead, I'll pass it to you maybe.
Has anybody got any questions there? If you have, I can allow you to talk if you'd like to pop your name into the chat box, or any questions. Other than we had some good questions there during the webinar. Colin was able to answer those. Go on, you have to tell us, what did you do with the to stop them murdering metal tables every week?
it was I mean, take the butter out an hour ahead of time. It was really
that simple.
It was that simple. Just let the butter around the edges melt so that it's not melt. I mean, it's still food safe, it's still good. You just warm the bucket up slightly and it comes out a whole lot easier.
As everyone knows, when you take the butter out the fridge, you can't spread a dry bit of bread straight away with it. And it's the same principle in the industrial setting as well.
That was great. Thank you very much, guys. Thank you, everybody, for joining. I don't see any questions, but if you haven't got any questions, something comes to your mind afterwards, drop me an email. You have my email address, or Colin or Charles. We will be sending you the recording. And thanks again for joining, gentlemen. Thank you very much. That was really, really good.